A very good day. Today we are going to learn sampling distributions of single mean by using Casio FX570 EX Classwiz Calculator. The lesson outline including sampling distribution, central limit theorem, sampling distribution of single means. The lesson outcomes, is by the end of the lesson, you will be able to understand the concept of sampling distribution and the central limit theorem, sampling distribution of single mean. In the previous lesson, we have learned the population distribution, which can be divided into discrete random variable and continuous random variable. Discrete random variable can be divided into binomial and Poisson distribution. However, continuous random variable can be divided into normal distribution. Both the population distribution is denoted by the random variable x, and the mean is denoted by mu, variance is denoted by sigma squared, standard deviation is denoted by sigma. Sampling distribution denoted by the, because it's from the population, we take the sample and then we find its mean. That's why it's called the sampling distribution. So it's denoted by bar x. The mean is denoted by the mu bar x. Variance is denoted by sigma squared bar x. Standard deviation is a sigma underscore bar x. Let's say this population, by taking a few data out, this is what we call sample. So sample is used to represent the population in a study. And then sampling distribution of sample means. Mean from just now population. You may take two sample, or three sample or four sample. So each sample that we take, then we find their mean. So we got sample 1 mean the bar x1, bar x2, bar x3, bar x4, bar x5. Come from the population with mu and standard deviation sigma. The sampling distribution consists of the value of the sample means bar x1, bar x2, bar x3, bar x4, bar x5. So mean from the population, you may take one sample, sample 1, sample 2, sample 3, sample 4, and then so as the sample size gets large enough, where the n greater than equal to 30, the sampling distribution become normal, become almost normal, with the standard deviation of the mean of the sample equal to the sigma divided by square root n. So the sampling distribution when n less than 30 are not normal, but when n greater than equal to 30 are approximately normal. Central limit theorem said that for a large sample size n greater than equal to 30, that taken from any population, normal or non-normal distributed, the sampling distribution of bar x of the mean of the sample population x is approximately normal, with mean of the sample mean of sample mean equal to mu. And then standard deviation of sample mean equal to the sigma divided by square root n. And the z-score is a bar x minus mu divided by mean of standard deviation of sample mean, which is sigma divided by square root n. To calculate the probability of single mean, first step we find the mean of the sample mean of sample x. So mean of sample x is equal to the mean of population. Standard deviation of sample x equal to the sigma divided by square root n. Write the distribution in normal form. Calculate the probability using z value, which is a bar x minus mu divided by sigma divided by sud n. For example, you are testing the voltage output of a batch of 50 semiconductor components, and you find that the population mean voltage output is 20 volts. So this is mu, okay, with a population standard deviation 1.5 volts. So this is sigma. Find the probability. So P, that 4 component, okay, sample site is n. This is a population site 50. Have a mean voltage output of 18 or lower. So mean here n is 50, mean mu is 20, sigma is 1.5, lowercase n equal to 4, and then okay, we are going to find the probability that the bar x greater and equal to 18, got 18 or lower. So step 1, it finds the mean of the sample. Mean of the sample. Mean of the sample is equal to the mean of population. Standard deviation of the sample will be equal to sigma divided by sud n, which is 1.5 divided by sud 4, which is 2, so 0.75. Step 3, the mean of the sample x satisfy normal distribution with the mean of the sample x and the variance of the sample x, which is equal to the mean, which is step 1, 20. Okay, variance will be 0.75 squared. Then step 4, we want the probability of the mean of sample x less than, find the probability that 4 component, okay, mean voltage output of 18 or lower. So mean is 18 or lower. So it's less than or equal to 18. 18 or lower. And then bar x convert to z score will be 18 minus mean, which from step 1 divided from the standard deviation in step 2. Then we get this value, and then we can use the scientific calculator easily. We use a distribution menu. Okay, menu 7, normal CD. Okay, the z score less than. So mean maximum is negative 2.6667. Minimum will be a small lower is a small value. So put the negative, because this is a left tail area. So I put a small value, let's say negative 10 times 10 to the power of 99. Upper, okay, I will key in the original one, which is 18, mean the z score, 18 minus the mean from step 1, 20. Okay, divided standard deviation that we obtained in step 2, 0.75. So you get here this value. Sigma, okay, the sigma for z score will be 1. Mu is 0. So you get 0.0038. Okay, we may also key in term of the bar x instead of in term of z. So if we key in term of bar x, okay, the lower still the same thing because this is left tail. Lower is a small value, negative 9 times 10 to the power of 99. Okay, and then my upper value will be 18. Upper is 18. So in this case, if we key in terms of bar x, this is upper, and the sigma is from step 2, 0.75. Okay, mean step 1, which is 20. So you see, both leads to the same answer. So I repeat, okay? If you key in terms of the original bar x, this is a left less than 18, so this is a upper value, lower is a small value, and then the standard deviation sigma is step 2, mean is step 1. If you key in terms of z, okay, lower is the same, upper will be this thing, 18 minus 20 divided by 0.75, or okay, you already calculate it, okay. So I will, if you use in the same distribution menu, okay, I will, okay, straight away key in here and it give me this value. And then if you key in terms of the z, sigma is 1, mu is 0. Okay, so with this, thank you for your attentions.